So last time we discussed how practically implement circuit using circuit cycle library. And then finally we discuss how Boolean algebra could be used to simplify circuit. Now, for example, in the last example we have discussed, we have this circuit Q equals A dot B plus C dot, then we have B dot C, right? So if you have like, very complex circuit like this, we can start writing the Boolean expression like this, and then we can try to simplify using whatever the laws that we have discussed, right? Now here, what we did, we got A dot B plus, then we actually expand this expression. So here we have BC and then we have B plus C. You can multiply this. So this becomes, when you multiply BC with B, we have BBC plus we have CBC. So if you have this situation, you can see this becomes A dot B. And when we have B dot B, we discussed this earlier, right? B dot B is B, right? So this becomes B dot C. Similarly, when you have BCC, you can B dot C, C dot B is same as B dot C. So when you have C dot C, it will be C. So basically we will get A dot B, B dot C, B dot C. So when you have B dot C, B dot C plus B dot C means B dot C. We discussed A plus A is A, right? So from the equations we discussed, A dot A is A, right? If that is the case, now then what we could do, we have common value. We have common value. We have A dot B, B dot C. So we can take B out, we'll get A plus C. So this complex circuit where we had 1, 2, 3, 4, 5 gates. So here we need 5 gates for this. It actually simplified into only 2 gates. So this is exactly what we are going to do. Right. So today I'm going to give you like a couple of Boolean expressions. So let's try to simplify. So I will give you a chance you to try first, and then we are going to discuss the answer, right? So the first one, let's start with this. We will have this equation. Let's say we have the first one. We have given as Q, right? XY. So when you have XY, it means X dot Y plus X dot Y plus Z plus Y dot Y plus Z, right? Let's try to simplify this. So let's try to simplify this. The first step, what I'm going to do, right? I'm going to take out the brackets. So we have XY plus, so I'm going to multiply X with Y plus X. So it becomes XY plus XZ plus, you are going to say multiply Y with Y. So it will be YY plus YZ. Okay. So that's the first step, my one, right? I think yours also the same. Right? Yours also the same. We get exactly the same answer. Now we'll try to simplify what we have. Now, when you're simplifying, you have to see what you have right now, right? Now, for example, here we have XY plus XY. It's like A plus A. Idempotent law, we say A plus A means A, right? So similarly, XY plus XY means XY, right? So we will have simplify with that. We can say XZ plus YY plus yz, right? This is actually using, if you want to say, using idempotent law, right? Idempotent law, because we know that xy plus xy is xy, right? Now that we have this, now let's look at what we can do next. So actually, this one also we can see, we have y dot y. This is also simplified for y. We can have it like this. You don't need it's the same thing, right? So we can have single y here, right? So I did two things, x dot y, xy plus xy, and y dot y also y. Now I'm trying to simplify this. Now to simplify this, now I can see there are a lot of y's out there, isn't it? So here we have a y, here we have a y, here we have y. So I have xz. So I will take xz here, and I'm going to take all the y's down here, right? So I'm going to say xz, right? Plus, I can now take out y, right? I can take out y. So when I take out y from all the expressions, we left with x, right, plus 1, isn't it? 1 plus this is, isn't it? Agree, Kantu?
Yes, sir.
So when you have this, right, since we have all y, we have 1 plus something. We don't know to know what values are here. It could be 0, it could be 1. These are Boolean variables. මේක තියෙන බූලියන් විචලන පුතේ. එතකොට මේක එන්න ඕනේ එක්ක බිංදු එක්ක එක මොක ආවත් එක තියෙන නිසා මේ ටිකේ එකතුව මොකද වෙන්නේ? මේකේ උත්තරේ කීයද? 1 plus
1.
yeah, it should be 1. So simplify this. The shortest one I can take it for this is, I can say xz plus y, right? පුතාගේ කී ළඟටම ඇවිල්ලා තියෙනවා. නමුත් අර y පුතා එක පැත්තකට ගත්ත නිසා එතනදී පුතාට පේනවා ඇති එතන ප්‍රශ්නයක් තියෙනවා කියලා. හරි. बाकी යට එකේ තව පොඩ්ඩක් සුළු කරලා y එක පැත්තකට ගත්තා නම් පුතාගේ උත්තරෙම එන්න ඕන. Right, let's take down. You write down what happens here. Actually, we are using identity law, right? 1 plus something, right? So using identity law, we simplify this. Okay, right. Let's take down this and we'll try the second one. Okay, let's try to simplify this. Right. Okay, first step. I'm trying to expand this expression. We have a plus c. Okay, actually, I can simplify this easily. If you look carefully, we have ad plus ad, but meaning I can simplify here, right? So I'm going to keep this one, a plus c within this, I will take out A. Then what will happen? We will take D plus D bar we'll get. Plus AC plus C. From the laws, we know that D plus D bar, like A plus A bar, because this is Boolean, Boolean again, that becomes 1, isn't it? So we will take A plus C. Then this will be simplified to A plus AC plus C. Right, this is good. Your answer is correct. From this, what I can do, I can multiply A dot A. So we will have AA plus AC plus AC plus C. So A dot A, we know it's A, plus AC, we know it's AC plus C. Right? Now we know A is here, C is common. So I can say A plus 1, isn't it? Yes. A plus 1, we know it's 1. So the final answer is A plus C. Good that you got the answer. Right? Third one is a very simple one. Let's try to do the third one then. Yes, try the third one. Right, that is also good. Okay, so let's try to simplify this. When you want to simplify this, So this one, you can do it actually in one line if you remember what we did. Remember the last law that we have done? Not the last one. Eighth one? Remember eighth one? Do you remember the eighth one? What was the eighth one, Cullen?
Distributive law.
Yeah. So do you remember what you mean by distributive law? If we have like A dot B plus C, we can say AB plus AC. Right? That is what we call distributive law. So in the distributive law, what is the second one? Have we discussed the second one? So one thing I think we have not discussed this. So let me discuss this, Kanta. මම හිතන්නේ මම මේක එහෙම කතා කරේ නැහැ ඒක නිසා දැන් මේකෙදී I'm going to do a simple change. This and I'm going to make it O and O's to N, right? So this is actually second type of what we call the distributive law. Right? The same thing, but if you change this, that means A plus B dot C. This is a second form of distributive law. Right? And this is simply the idea of dot becomes plus, right? Dot you can try this with the you can try this with the truth table if you want. Truth table එකකින් පුතාට මේක බලන්න පුළුවන් මේක මෙහෙම වෙනවද කියලා. But you have already seen now when you multiply, if you remember this distributive law, then we could have written in single shot, right? Simply we could have written like A plus B dot C. But I think what you have done is okay. So we simplify AA and then AC, then BA, that means AB and BC. Right? So that's what you did. And then, like we have seen earlier, we know that A is common to everyone, so we can take it out A. We will have 1 plus C plus B plus BC. So simply this is A plus BC, right? So that's what we got. And I think your answer is correct, right? So no errors, but what I want to say here is we could have written in one shot. අපිට කෙලින් තනි පියවරෙනුත් ලියන්න තිබ්බා distributed law කියලා දාලා මේ දෙක දිහා බලපු ගමන් මේක ලියන්න පුළුවන්. එච්චර මතක තියාගන්න ඕනේ නැහැ පුතේ. විභාගදී සුළු කිරීම කරලා කරාට කිසි ප්‍රශ්නයක් නැහැ. Right? So let's move on to the last one. Okay, let's try this. Right, let's try to simplify. ඇයි මේ අන්තිම උත්තරේ සුළු කරේ? In the fourth one, we have cube a b bar plus a bar plus b into b bar plus b. So this is a b bar. From the De Morgan's theorem, if you have a b bar, this is equal to a bar plus b bar. And then here we have a bar plus b, this is 1. So here we have a bar, so that becomes a bar. B bar plus b, that becomes 1. So if you add anything to 1, it should become 1, isn't it? Right. Some homework you can try. I will just write without q, right? You don't just try to simplify this. This is the first one. Second one. I think we have done some of the things. So a b bar plus this is exactly the same thing. So the second and third one, yeah. It's the same thing. Slightly different one. Huh? Yes. And then third one. Anyways, this is we have already done. Third one order a plus ab. Fifth one a bar a plus b plus b plus a plus b bar. Right. Try this and then we can discuss this next week. hypothetically, yeah. Right. Okay. It's let's discuss how we can simplify logic expression using Karnaugh maps. So to discuss this, I'm going to go step by step what you should do. So we are going to have like a kind of a map we call Karnaugh map, right? I'll explain what the Karnaugh map is. Right. Let's write down what Karnaugh map is. The Karnaugh map is a method of simplifying Boolean algebra expressions. Now, if you ask me like why Karnaugh maps, because we have already used the if you ask me like why Karnaugh maps, why not use of Boolean algebra, right? So there should be a reason why we are using Karnaugh map. So if you ask like why then Karnaugh map, it's easy, right? We have not done it yet, but you will see it's easy compared to Boolean algebra. We can say it reduces logic expressions more quickly and easily compared to Boolean, right, algebra. So we can see this later on, but for the time being, let's write down why we need Karnaugh map. එතන අපි කතා කරපු විදිහට පුතේ Karnaugh map කියන එක අර වඩා easy, ගොඩක් lazy. අනික variables ගොඩක් තියෙනවා. විචල්ලේ ගොඩක් තියෙන වෙලාවදී මේක ගොඩක් lazy කියලා කියන්නේ. Now, first of all, let's look at how we can define a Karnaugh map, right? So step one, so this is you should do, right? The first step. Now, once you have this, this is what you should be doing, right? As a first step, right? So you first look at number of variables you have given in the expression. අපි A, B තියෙනවා, A, B, C තියෙනවා, A, B, C number of Boolean variables බලන්න. So based on number of variables, in the number of variables in the Boolean expression, right? Draw table. I will explain how you are going to do this, right? But when you're drawing the tables, number of rows and columns, the total should be 2 to the power n. So which means if we have two variables, then it should come with 4 cells, right? I will explain again. So I'm going to say, yes, I'm going to have if number of variables are in, then number of cells should be 2 to the power n. I will put a hat mark, but you don't have to hat mark. You can say, like this. Let me draw. Should be you can say 2 to the power n, right? So that means if you have one variable, then you need 2 cells. If you have 2 variables, you need 4 cells. If you need 3 variables, you need 8, and so on. So let me give an example, like, okay, example, Carnot map for 2 variables. අපි expression එක අපි හිතමු variable දෙකයි තියෙන කියලා. So this is what we are going to do. So we are going to draw a simple table like this. So since you have 2 variable, 2 to the power 2, you need to have 4 cells, right? So I'm going to draw 4 cells. Should be like this. And then I'm going to have represent 2 variables. Let's say I have like 2 variables, A one side, and then we have B this side. Right now, usually when we have this, we know in B there are 2 states. The values that B can take is 0 or 1. A also can take 0 or 1. So which means this indicates that, right, both multiplication of A and B. So when you say 0, we can take it as a bar. So this cell actually represent A bar and B bar. The value represent, right? Maybe I will use different color. Right? Let me take different color. Right? So this one is actually, this cell represent the value of A bar B bar. It's actually not A bar B bar, whatever the value, right? So this represent A bar B bar. Similarly, this is when you say A0 mean A bar, and here 1 means B. So this cell actually represent the value of A bar and B. Similarly, when you have here, we have A, from B side it's B bar. So this one is A, and this side we have B bar. And from here it will be A. From here it will be B. So this is the how we draw a map. In the map, we have two variables, and then we represent all possible combination with these two variables, right? So when the value is 0, we usually say bar. So when you say A, 0 means A bar, B 0 means B bar, A 0 means A bar, B1 means B. When you say 1, it's A, 0 means B bar, and finally we have AB. Finished? Let me know when you're finished. Right now, another example. Let's say next one, I'm going to have Carnot map for 3 variables. So when you say Carnot map for 3 variables, let's for one side, we'll take one variable. The other side, I'm going to take 2 variables. In the one side, let's say A, we have 0 and 1. The other side, we have 2 variables. So we have to write down all possible combinations. So it's perfectly all right to say 0, 1, right? B0, B0, C1. Sorry, we'll start with 0, 0. We'll have 0, 0. And then we can have 0, 1. Right? Okay, remember, not 1, 0, but before that, we are going to use 1, 1. Okay, it's like this. Now, we put 1, 1 here because from the previous one, it's always 1 bit change. Now, here we have 0, 0. You change this bit, you will get 0, 1. Then you change this bit, you will get 1, 1. And then we'll get 1, 0. Okay, remember this is very, very important when you write down how this actually represent. The reason is like always it should be 1 bit change. Always it will be 1 bit change. Right, now let's write down the variables. Now when you have